A very good morning, students. In this video, we will be discussing sorting. Sorting is arranging a list of elements in ascending or descending order, and it is a very common activity that we have to do on a day-to-day basis. And there are certain algorithms, 4 of them we will be covering, 5 of them, and which help in making the sorting process easier. So the first algorithm that we are going to cover is bubble sort. In bubble sort, it is the most primitive sorting algorithm, and its complexity is n square. That is, there are two for loops involved, which will run n times, and it compares the adjacent elements in the array and brings the largest element towards the end of the list. So in bubble sort, whenever one pass will complete, the largest element will come out to the highest position of the array. So if the array is from 0 to 6, then after the first pass, the largest element of the array will come at the 6th position. Then in the next pass, the largest element will come to the 5th position. Then in the next pass, the third largest element will come to the 4th position. This way, each time the algorithm will pass through its loops, the first largest, second largest, third largest element will keep on coming to their positions in the ascending order. Now, as we have said that there are 2 loops in a bubble sort algorithm, the algorithm is very simple. It is only the statement that we compare the 2 adjacent elements and the larger one will move towards the end. This is the crux of this algorithm. And if you understand and memorize this statement, writing the algorithm will not be difficult. So the first part in the algorithm is that there are 2 loops. Why 2 loops are required? 1 loop is required so that we process the algorithm for each element in the array. And the second loop is required so that we compare each element with each of the other elements in the array. So the first loop, it is going to control that we are going to sort all the elements which are present in the array from 1 till n minus 1. Why n minus 1 here? Because the last element will get sorted automatically. If we sort n minus 1 elements, the nth element will automatically get sorted. Therefore, we don't need to run it till n. We will run it till n minus 1. Then the second loop from 1 to n minus I, because we are already sorting the highest element in the last position. So we know that in the n minus ith position we have the largest element. So we don't need to touch it because we are trying to find the second or the third or the fourth largest element in the array. Therefore, the second loop will work from 1 to n minus i's value it will be taken from the outer for loop. And within these 2 loops, we have the statement, if a of j is more than a of j plus 1, then swap a of j with a of j plus 1. That is, you move the larger element in a of j plus 1. So the algorithm is very simple. You have one loop from 1 to n minus 1. The second loop is from 1 to n minus I. And within these 2 loops, we have an if statement which says if a of j is larger than a of j plus 1, then we will swap a of j with a of j plus 1. So as we can see in this example, we will come to this slide later. So in this example, we have these index positions 1, 2, 3, 4, 5, and let this be the array to sort. The array is 5, 3, 2, 7 and 1, and I will be 1, j will be 1 to n minus I. So n is 5, 5 minus 1, 4. So I is 1, j is 1, and j will execute from 1 till n minus I. So what we will do, we will compare a of j, which is a of 1, with a of j plus 1. So 5 is compared with 3. Since 5 is larger than 3, we swap the 2. Then we compare 5 with 2. 5 is larger than 2, so we swap both of them. So we get 3, 2, 5, 7, 1. Now we compare 5 and 7. Now 5 is smaller than 7, so we don't do anything. Then we compare 7 with 1. 7 is larger, so we swap 1 and 7 and we get 3, 2, 5, 1, 7. After the first pass in which I was 1, and we have moved from j is equal to 1 to 4. Till here we have compared. Now we will see that in the fifth position we have the largest element of the array. As we have already discussed in the algorithm that the largest value will fall in the last place in the array. Now since this element is already sorted, we don't need to run an algorithm till this position. So what will happen? I will become 2 and j will become equal to 1 to n minus I. So j will be 3 now. That means till here we will run the algorithm. Now again we will compare 3 with 2. So 3 is larger than 2, so we swap. Then 3 is compared with 5. Now 5 is larger, we don't do anything. Now 5 is compared with 1 because a of j is compared with a of j plus 1. So a of 3 is compared with a of 4. And since this 1 is smaller, so we will perform a swap operation here. 1 will come here and 5 will come here. Now we will see that after the second pass, these two numbers are sorted. And now we'll have to look at this remaining array. So now the algorithm will run from I is equal to 3 and it will run from 1 to 5 minus 3, which is 2. So a of 1 and a of 2 will be considered. So we compare this with 2 with 3. These are already sorted. Then 3 is compared with 1. Now 1 is smaller, so we will swap it. Now in this run, the third largest element is in its proper position. Then we run the loop for I is equal to 4 and j is equal to 1 to 5 minus 4, which is 1. So a of j is compared with a of j plus 1. So 2 is compared with 1. 1 is smaller, so it will move to the beginning and we have the list sorted with us. Now, this is an easier version of this algorithm. Okay, in this what we are doing, I is equal to 0, I is less than n minus 1, I plus plus. Now since we are starting from 0, that is why we are going to less than n minus 1. And in the inner loop we have j is equal to 0, j is less than n minus I. And if a of j is more than a of j plus 1, then we will swap using the temp variable. And in the end we print the sorted array. I hope the bubble sort algorithm is clear. If it is clear, you can like the video and subscribe to my channel. Thank you.